All right, welcome to our lesson on metric system. You'll want to pull up the metric system document from Google Classroom for us to get going. Now, I got to do a little intro on this one. I provided a couple charts. So one of them is a general metric conversion chart. So here's the base ones that you would use. So the base unit, and then it just moves 3 on each side. And talking about how the decimal is really the only thing that changes because it's a base 10 system. Now, if you go beyond just 3 units above or 3 units below or 3 sets of 10 above and below, I gave you a second one, and this is all of them. This is the crazy ones. So this is benchmarks all the way to just crazy numbers. A Yada meter is not even something that like exists and can be measured. Like that's ridiculously large in that's not even in our solar system. It's that big. So there's some very, very large numbers there. So you'll want this one pulled up for our distance measurements. And let's go right ahead and begin.
The base unit for distance in the metric system is the meter. And to get a sense of how long a meter is, the average human being is between 1.5 and 2 meters tall. So 1.5 meters would be a not so tall person, but 2 meters would be quite tall. In fact, if you're 2 meters tall or above 2 meters tall, you might want to consider basketball. So for example, in this drawing right over here by Leonardo da Vinci, a meter, if this is an average sized male, a meter might be about, it would be more than halfway across his wingspan. So it might be about that much. And obviously I am just roughly drawing this just to give you a sense of how far a meter might be. And I just wrote a lowercase m here as really just a short way of writing meter. So you can imagine at the smaller things that you might want to measure with the meter are things like a human being's height or a human being's wingspan. If you wanted to say, well, what are some of the larger things that you would want to measure with a meter, you might imagine something like the height of a skyscraper. So this right over here is the Empire State Building, once at one time the tallest building in the world, now just a tall building in the world. And this is 443 meters tall. 443 meters tall. So this is starting to be kind of on the larger scale of things that you would want to measure with a meter. Now you're probably asking, well, what happens if I want to measure things that are even larger than that? Well, the metric system provides us prefixes to essentially say multiples of meters. And the one that's typically, the unit of distance that is larger than the meter that is most typically used is the kilometer. So the kilometer, I've heard a few people say kilometer, but kilometer, I'll pronounce it kilometer, which is equivalent to 1,000 meters.
Make sure that you know that prefix. Kilo means 1,000. That's a very important one to know.
And so when you're thinking about kilometers, this is thinking about the distance within a city. This would be even the distance from one city to another city. Even the radius of the planet is often measured in kilometers. And to once again get a sense of that, this right over here is a map of New York City, and right over here they give us the scale. This distance right over here is 5 kilometers. So 5 kilometers, just to give us a sense of things, and they wrote km for short. So 5 km, this lowercase k, lowercase m is the shorthand for kilometers. This would be equal to, well, if 1 kilometer is 1,000 meters, 5 kilometers is going to be 5 times as many. It's going to be 5,000. 5,000 meters is this distance right over here. If you were to try to imagine 1 kilometer, it would be 1/5 of that. So 1 kilometer on this map might look something like that. Now there's other units in the metric system that allow us to describe distances less than a kilometer but more than a meter, but they're not as typically used. But I'll list them here just so that you see that they exist. You have the hectometer or hectometer. It's so infrequently used that I really haven't heard a lot of people say it, which is equal to 100 meters. And you have the decameter or decameter, and I actually think it's decameter, which is 10 meters. And I'm going to write these in orange because they're not that frequently used. For example, no one would ever say, or it's not typical to hear someone say that the Empire State Building is 4.43 hectometers, or for them to say that this is 44.3 decameters. They would typically say that this is 443 meters.
Now, I want you to appreciate what he just did. He just did 3 conversions on the fly in the same sentence. And that's not because he's amazing. It's because of the metric system. So the idea here is that you just move the decimal spot. So if a decameter is 10 meters, that just means you move the decimal spot 1 point. So if it's 443 meters, you just move the decimal point. Oh, it's 44.3 decameters. Oh, you move it again for hectometer, go right ahead and move it. Oh, it's 4.43 hectometers. If you want to go kilometer, kilometer, what was that? That was weird. You move it 1 more and it's 0.443 meter or kilometers or kilometers. So just like that, you can convert just by moving that decimal point. You don't need to remember all the conversions. You only have to remember the prefixes. Continuing.
Now you're probably saying, okay, well, this is fine. I'm able to, using these prefixes on the meter, I'm able to describe distances that are larger than a meter, that are multiples of tens of the meter, or multiple of 100, or multiple of 1,000 of the meter. But what if I want to go smaller? Well, the metric system has units for that. And if we go just 1/10 of a meter, this is not used as typically, but I'll write it here. The decimeter is 1/10 of a meter.
You do see those on rulers that have centimeters.
Or another way of saying it is 1 meter is equal to 10 decimeters, lowercase dm for short. Once again, this is not so typically used, but if we go 1 scale even below that, we get to the centimeter, which is a heavily used unit. We get to the centimeter, and here the prefix centi means 1/100th. So this is 1/100th of a meter. 1/100th of a meter. Another way of thinking about it, 1 meter is equal to 100 centimeters. And if you wanted to imagine the scale of a centimeter, you could imagine this frog right over here on this person's hand might be several centimeters long. So a centimeter on this drawing might be around that distance. Now, if you want to measure things even smaller than that, we have another fairly common unit, and that is the millimeter. That is the millimeter. And the prefix milli here refers to 1,000th. So it's 1,000th of a meter. Or another way of thinking about it is 1 meter. 1 meter is equal to 1,000 millimeter. Actually, let me just write.
All right, so let's go right ahead and take a look at our document here. And I'm going to show you how I do this. So I'm going to stop the share, boop, full screen. So I've set up all the particular problems. So the key here is you're going to want to look at that prefix sheet. And here's how I actually go about doing this. So the base unit is the meter in this case. So a base unit is 10 to the 0th power because it's just 1. It's the base unit. So it's just base is 0. So you just plug in the prefix there, means 0. Kilo means 10 to the 3rd power. The way I do this, and by the way, guys, I created this particular method, so you're not going to find this method really anywhere else, but I feel that it works the best for me. You just take the difference between these numbers. So 0 and 3, the number of differences between them is 3. So what's a 1 with 3 zeros behind it called? 1 with 3 zeros behind it is 1,000. There are 1,000 meters in a kilometer. Now let's go on and see if this works for all of them. So kilo, again, is 10 to the 3rd. Now, mega, you might need to look up on that document, but mega is 10 to the 6th power. Now, again, the difference between those numbers, the number of steps between them is 3. So again, what's a 1 with 3 zeros behind it called? There are 1,000 kilometers in a megameter. Now, base, again, is 0. Exa. Now, exa is pretty crazy. It's 10 to the 18th, and we write that like this: 10 to the 18th power. So the little caret symbol, meaning it's an exponent. So that just means the difference between those is 10 to the 18th, or a 1 with 18 zeros. So I'm just going to put 10 to the 18th. Mealy. Now, mealy is -3, and the base is 0. So you might be tempted to say, oh, it's -3. Well, the difference in number of steps is still 3. So what's a 1 with 3 zeros behind it? Again, 1,000 millimeters is in a meter. Centi to the base. Centi is -2 on that document. Centi to the 100th. Base is 0. So again, your difference there is 2. So a 1 with 2 zeros behind it is just 100. And then finally, our last one, centi to kilo. Centi is -2. Kilo is 10 to the 3rd at this point. So the difference here is there are 5 steps between them. And what is a 1 with 5 zeros behind it called? Well, once you put it out, 100,000 centimeters in a kilometer. So you can just plug those in to that particular document. All right, so let's take a look. So we have, again, 1,000 meters in a kilometer. We had 1,000 kilometers in a megameter. So that's just the prefix differences. This one is 10 to the 18th, because I don't think you can really fit a 1 with 18 zeros behind it there. So we're going to shorthand that one for sure. Mealy, again, was 1,000. So the idea of it was -3rd to the base. Centi is 100, centi, and 100,000. Now let's go right ahead, and instead of doing separate videos, we're just going to put this all in the same particular video here on this one. So let's go to units of weight.
It's typically used in the metric system to measure an object's weight. And I'm putting the weight in quotation marks right over here because the units I'm going to too much stuff there. A weight is what have more mass, and that's why things. For the sake of sense, not in the text, they will often stick of chewing gum, average size paperclip. And to get a sense of things that weigh a gram, one example is a paperclip. Your